All right, so let's look at this problem. 8-7. So what do we have? We've got 3 blocks, A, B, and C. You can see they all have different weights from the top down. 50, 35, and 35. Yeah, and 15. I think I wrote that problem down wrong. Hang on a second. I believe that's 25, not 35. So this is incorrect. Let's put 25. And then you have coefficients of static friction between A and B, a 0.3, between B and C, a 0.4, and between the block and the ground of 0.35. And we're going to find the smallest force P that causes this thing to pull out. So what will our strategy be? Well, let's first look at the situation. More than likely, when I'm pulling to the right, block A is not moving at all. Right? So there's two possibilities. One is I will pull block B out, and block A and block C will not move. Okay? Kind of like pulling it out from the middle. The other possibility is that I pull to the right, and blocks B and C stay together and slide as a group. So they would separate at A and D. So you see the two cases? I'll start off with the first. I'll do a case where, let's see, block B will pull out and leave A and C motionless. So let's do that first. So I'll draw a free body diagram of this system. I'll start with, maybe I'll do it down here. So here's the first block. It has a force of 50 newtons. And it would have some force in this direction. I'll just call it T. And then on the surface, I'll have a normal force and a friction force. Now let me wait on the friction force just a second, because if I pull block B out, B will move to the right. So if I look at the friction force on block B, which direction should it be? If I'm pulling it to the right, P, I should have friction forces to the left, right? Mm-hmm. On both surfaces. Of course, I'll have a normal force and normal force. Let me give these things some I'll just call this normal 1 and friction at A. I'll call this normal 2. Friction at C, and then I'll also have the weight of the block, which is 25 newtons. And then finally, my bottom block, block C, has a weight of 15 newtons. And at this interface between C and B, I have the same normal force. Friction force is opposite. I have a normal force. Call it N3. And I'm not going to worry about the friction force right now. Let's just say it moves in this direction. Probably won't need it. So if my friction forces on block B are to the left, then they should be equal and opposite. That's a lot to take in. And I'll just call this free body 1, 2, and 3. So let's apply our equation and see what we can get. Looking at free body diagram 1, I should be able to solve for the normal force very quickly. So I'll come back up here and say from free body 1, if I sum forces in the y direction, assuming up is positive, what do I get? Well, I get my 50 newtons acting down, and I have what I call N1 acting up. So it looks like N1 is going to be 50 newtons. Now, why do I care about that? Well, since I know that, or I'm assuming that the block B is going to move to the right, then I know I have a friction equation that I can use here to find the actual friction at A. I'll hold on to those for a second. If I go to free body diagram 2, I now know N1, so I should be able to find N2, and I should be able to sum forces in the X direction and find P. So first what I'll do is I'll sum forces in the Y direction. Let's see what I have. So I have N1 acting down minus the 25 newtons acting down plus N2 acting up. So it looks like N2 is 75 newtons. Now, since my goal is to get P, I can now sum forces in the X direction on body 2. Let's see what I get. So I got P acting to the right, positive, and I've got 2 friction forces acting to the left. The friction force at A minus the friction force at C. But remember, I know those, I have friction force relationships. I know that the friction force at A is the coefficient of friction between A and B times N1, which I know. And I know the friction force at C is that coefficient of friction at C times N2, which I know. This equation just tells me that P is equal to those 2 friction forces. So I should be able to solve for P. I'll get mu A, which is 0.3, times normal 1, which is 50. So that's friction force A, plus friction force C, which is mu C, which is 0.4, times the normal force there, which is 75. So let's see what that number is. 50.3 times 75.4 times. Looks like it's 45 newtons. So if I apply a force of 45 newtons at P, that would pull block B out from A and C. See that? Is that the only possibility? No. So let's see if I can kind of block the problem off and look at the next possibility, which is that B and C stay together, and when I pull to the right, I have separation at A and separation at D. So now my free body diagram look different. So here's the 2 blocks staying together. I still have my force P applied here at block B. Now I'll have same normal force from the top coming and the same friction force. I call it friction A. this is the weight of block B, and this is the weight of block C, and then on the bottom at point D I have a normal force, I'll just call that 3, and since we're moving to the right, the impending motion is to the right due to the force P, my friction force, I'll call it friction D, is to the left. Okay? So, what do I know? Well, I know N1, that hasn't changed, so I know FA. So what I don't know are these two things, and P. So I should be able to find the normal force at 3, and I should be able to find P as a function of the two friction forces. So let's sum forces in the vertical direction first. So I have N1 acting down, minus 25 newtons, minus 15 newtons, and then what's acting up is N3. Remember, N1 is 50, so you add that all up, it looks like N3 is 50, 75, 80, 90. Okay? So now I'll sum forces in the x direction. Let's see what I get. We'll have P to the right, then minus the force at A, friction at A, minus the friction at D. So again, it looks like P is just going to be friction at A plus the friction at D. Now I can write those equations, right? Remember, I know that at A, the friction force is mu A in 1, and I know the friction at D is mu D, what I call it N3. I know all that, so I can simply solve for P. So the force at A, the coefficient of friction is 3, N1 is 50, plus the friction force at D, the coefficient of friction there is 0.35, and the normal force is 90. So let's see what that is. I got 46.5. So which one's going to happen first? 45 or 46.5? 45. So this becomes our answer. So when you apply 45 newtons force, what's going to happen? Block B will pull out between A and C will stay in motion. Will stay motionless. Okay? Questions about that one? All right. We'll stop that.